So the homework in this section is going to be like this. First of all, here's what it is. It's page 725 in your Stewart-Kokoska, number 10, 14, 20, 22, 27, 30, 46, and 56. A fine selection of problems that I handpicked just for you. And those will be posted on the blog if you have any trouble reading them or you just don't want to right now. All right, so here's what they're going to ask you to do. It's the typical kind of thing. You're going to find a power series for some function that they give you. So it'll say something like, this is an example, this is number 12 in the homework. Find a power series and determine the interval of convergence. So that's the kind of thing we got to do. So they give you some weird function, right? Now, the only function you know about is this one, 1 over 1 minus x. So basically you have to manipulate this to make it look like this. So, and you could use an integral or a derivative. You could also, instead of starting with 1 over 1 minus x, you could start with one of the ones that we already derived here, right? So you could start with one of those, one of these ones maybe, all right, as a starting point. So start with one of the functions that you know. So this one, I don't see any x squareds or ln's or anything, so I'm thinking that I want to try and make it look like 1 over 1 minus x. So what I'm going to do is try and make this function look like 1 over 1 minus x. So the first thing I'm going to do is I'm going to pull out a 4 from it so that I can have 1 in the top. So at least that's a start, 2x plus 3. Right? Now, I need 1 minus x. I need this number to be a 1. So what I'm going to do is factor a 3 out of the bottom. So if I factor a 3 out of the denominator, that's going to make my 4 turn into 4/3. And then I'm going to have 1 over 2/3 x plus 1. And then the other tricky thing is we've got to turn this plus sign into a minus sign. So we just use negative 2/3 x. So this equals 4/3 1 over 1 minus negative 2/3 x. So basically what I've done is use algebra to rewrite the function so that it looks like this guy, and then this is what I'm going to substitute for the x. So instead of sum of x to the n, I'm going to have sum of negative 2/3 x to the n. So I'm going to start with, I have sum n equals 0 to infinity of negative 2/3 x to the n, and then this 4/3 just goes out in front like that. And so that's my power series right there. I mean, that's it. The next thing that they ask for is the interval of convergence. So in all the ones that we did before, the interval of convergence has stayed the same. It stayed negative 1 to 1 because we didn't replace with anything except x squared. So this time we're replacing, right, what we did here was we replaced the x with negative 2/3 x. Well, our original interval of convergence was absolute value of x is less than 1. That's for your convergent geometric series. All right, but our x is really negative 2/3 x. So I have to solve absolute value of negative 2/3 x is less than 1, because really this is a geometric sequence, and the ratio is negative 2/3 x, because I'm going to have negative 2/3 x, and then I'm going to have negative 2/3 x times negative 2/3 x, and then negative 2/3 x times negative 2/3 x times negative 2/3 x. That's what the n up here is doing. So I have a geometric series, and the common ratio is negative 2/3 x. You can work out a couple of terms of this series to see what that looks like. Maybe we'll do that if we don't run out of time here. All right, so I just solved this then to get the interval of convergence. So negative 1 is less than negative 2/3 x is less than 1. So 1 is greater than 2/3 x is greater than negative 1. And 1 is, well, let's multiply by the 3/2. So 3/2 is greater than x is greater than negative 3/2. So when I write an interval, I always have to write the smaller number on the left. Negative 3/2 to 3/2 is the interval of convergence. And basically that's the idea of all the homework, is can you take one of the series that we knew and get the function they gave you to look like that by doing factoring, manipulation, substitution, maybe an integral or a derivative. Yeah, so I thought maybe let's look at a couple terms of this. So when n equals 0, I'm just going to have 1. And then when n equals 1, I'm going to have minus 2/3 x. And then it's going to be plus 4/3 x squared. And then minus, what is it, 4/3? It's going to be 4/9, right? Yeah, 4/9 x squared. And then it's going to be minus 8/12 27ths x cubed, right? So this is this is a geometric sequence. It's geometric, and the r is negative 2/3 x.